In example 1, we were given a specific value to test whether or not that was a solution. In 2 of the cases, we found it was a solution. In 1 case, it wasn't a solution. So we can answer that question. But really what we want to do in math is find the solution rather than being given a value and testing it. So one approach would be to try and test every single number until we find the value or values that are solutions. But that would be nearly impossible and would take forever, since we have an infinite number of numbers to choose from. So instead what we want to do is construct a process for how we can find the value or values that are a solution to a given equation. And to do that, we're going to set up a general strategy to find the solution to a given equation. We can follow the steps in this strategy below. Our first step is to simplify each side. So before we worry about the fact that we have an equation and expressions on each side, we just deal with the left-hand side and the right-hand side separately, combine any like terms, use the distributive property, other arithmetic techniques that we have to simplify as much as possible. Then what we'll do is collect all of the variable terms on one side of the equation, and we'll look at how we move terms from one side of the equation to the other. Similarly, we'll collect all of the constant terms, so terms without a variable component, on one side of the equation, or I should say more specifically on the other side of the equation. Then we'll make the coefficient of the variable term equal to 1. Another way to say that is those few steps are about isolating the variable on one side of the equation by itself. And then our very last step, which is too often skipped over, is to check our solution. This takes more time, but especially when it comes to a quiz or an exam where more points are at stake, checking your solution can be such a good idea to know if your answer is in fact a solution. So let's apply this general strategy to a few examples. In part A, we have n minus 3 is equal to 6. There's nothing to simplify with this expression on either the left-hand side or the right-hand side, or I should say with this equation. The expression on the left-hand side, the expression on the right-hand side have no like terms in common. There are no arithmetic steps we can take. So we'll go ahead and look at isolating all of the variable terms on one side of the equation. In this case, there's only one variable term, n, which is already obviously on one side of the equation, so there are no variable terms to move. But we do need to move a constant term to the other side of the equation. Since we have n minus 3, what we're going to do is add 3 to both sides of the equation. Then on the left-hand side, positive 3 and minus 3 will cancel each other out. So we'll be left with n, and just to put it in here as a placeholder to see what happened, plus 0 will be equal to the sum of those two values on the right-hand side. So that will be 6 plus the 3 that we added, giving us n is equal to 6 as our solution. Or I'm sorry, not n is equal to 6. N is equal to 9 as our solution once we add 6 and 3. So we added 3 to both sides of this equation. We can perform any arithmetic operation like that as long as we perform the exact same operation to both sides of the equation. We can add, subtract, multiply, divide, as long as we keep that balance, perform that on both the left and right-hand side. Then, as I emphasized, we want to check that we have the correct solution. To do that, we'll take that value of 9 and substitute it into the original expression, or the original equation, giving us 9 minus 3 is equal to 6. And again, that's that question, is this a true statement? In this case, we get 6 is equal to 6. As long as we end up with a true statement, then we know we found the solution to our equation. In part B, again, there's nothing to simplify on either side of the equation. So our starting point will be our next step would be thinking about collecting all of the variable terms on one side of the equation. That's already taken care of for us. B is on one side of the equation by itself, but we do need to add 1 to both sides of the equation to get that variable term isolated. So this will end up being negative b is equal to negative 6 plus 1, which will be negative 5. Now we have to look at step 4 in that general strategy, where we need to make the coefficient of the variable equal to 1. Right now, if we wanted to be a little bit more explicit, we could rewrite this as negative 1 times b is equal to negative 5. So whatever coefficient is being multiplied to that variable, we need to divide both sides by that value. Meaning in this case, we'll divide both sides by negative 1. Negative 1 divided by negative 1 will become positive. So we'll end up with b is equal to negative 5 divided by negative 1 will also become a positive 5. And then we can check that result by evaluating negative 5 minus 1 is equal to negative 6, which again is a question until we know for sure whether those two sides are equal. Negative 5 minus 1 will give us negative 6, which is in fact equal to negative 6, so our solution checks out, and we know we found the right answer. In part C, we have an additional step to take here, because now we have a variable term on each side of the equation. So we'll start off by subtracting n from both sides of the equation. We could also subtract 2n from both sides of the equation. It doesn't matter which direction we do this, as long as all of the variable terms end up on one side of the equation. So this will leave us with negative 4 is equal to 2 minus 1, or 1 times n. One times n is the same thing as just negative 4 is equal to n. So we have our solution. Because that coefficient is already 1, so there's no additional step, no division step to isolate n by itself. But then we can go ahead and check the solution. We'll have to substitute in negative 4 on both sides of the equation since we have a variable popping up on both sides. So the question is whether negative 4 minus 4 is equal to 2 times negative 4. On the left-hand side, negative 4 minus 4 will give us negative 8. And on the right-hand side, 2 times negative 4 will also give us negative 8. So again, our solution checks out, and we did find the correct answer for this problem.